Alright, so this is the last page of the 7-4 notes that we're reviewing. So this is the last sort of basic review of the different types of probabilities where we're always going to divide by the universal set. So the basic probability types using the Chapter 6 counting techniques before we get into the harder stuff in 7-6 and 7-5. So, problem number 8, the professor randomly assigns a 4-digit code to each of his students for the purpose of posting grades. Digits may repeat. So that means I'm throwing off combinations and permutations. They're off the table. I can't use them. Find the probability that the student's code contains no 5. So remember, digits are always 0 through 9. So there were 10 of them. This particular example, though, doesn't want you to pick a 5. So your code does not contain the number 5 in it. Alright, so probability that you do not pick the number 5. Well, it'll be the number in my event over the number in my universal. The event is I'm not picking a 5. I cannot use permutations nor combinations, so it's a straight multiplication because I'm allowed repeats. Alright, so we'll do the universal set first, right? The universal set, I'm picking a code of 4, right? I have to have 4 digits in my code, so those spots represent my digits. I just pick my first digit and my second digit and my third digit and my fourth digit. Well, I can pick any digits for the universal set, right? Universal set means that any digit can be chosen. And so there were 10 choices. So 10 times 10 times 10 times 10, or shorthand that to 10 to the 4th. Up top, the event is I'm going to pick 4 numbers for my code, but I cannot pick the number 5, which leaves me with, so I throw the number 5 out, so I have all of the other digits left over that are not 5. Well, there are 9, right? So it just throws one of them out. And so I had 9 digits for the first spot, 9 for the second, 9 for the third, 9 for the fourth. Right, there are 9 choices that are not 5, and since I'm allowed repeats, I have 9 for each of those. So 9 to the 4th is the event, and make sure you're careful. You know, when you're typing that out on the calculator, it's 9 to the 4th divided by 10 to the 4th, which comes out to 0.6561. So there's the probability that if you get a randomized code, the probability, a 4-digit code where you can repeat your digits, the probability you don't contain a number 5 is about a 65% chance, a little over 65% chance. Alright, the next example, suppose I pick exactly 1 5. Alright, so probability we get 1 number 5 in the code. Number of ways to get 1 5 out of my universal. And the universal is the same. It's going to be 10 times 10 times 10 times 10, so 10 to the 4th. So I'm not going to find that again. Alright, the hard part for this one is selecting the 5. So I'm going to kind of write down, so I'm going to do my event here. Number of ways to pick 1 number 5. Alright, well, first thing I have to do is I have to pick the 5. And the hard part to remember is it's like the sequence that we did before with the computer. Alright, not only do I have to pick the 5, but I have to place it, because the 5 could be in the first spot. Right, well, 1 5 could be in the first spot, or it could be in the second spot, or the third, or the fourth. So I have to pick 5, and then I have to place the 5 in the code. And then once I've picked it and placed it in one of the 4 spots in the code, I still need to pick 3 others, right? I have 3 spots left that are not 5. Alright, so when we write that out, there's 1 number 5, so there's only 1 way to pick the 5. There are 4 spots I can place the 5 in the code, so 1 times 4. And then I have to finish out by filling out the rest of my code with numbers that are not 5, because I've already picked the 5, and I only want 1 of them, so I can't pick another one. So once I've picked 5, I can't pick them again. And so that means there are only 9 numbers left for the 3 remaining spots. And there's 9 for all 3 because I can repeat those, right? I just can't repeat 5. So I can repeat the 9 and the 9. And so the event is 4 times 9 cubed. 9 times 9 times 9 is 9 cubed. Still over the universal set. I'm going to erase this. It's kind of running into my Alright, so the probability that I get 1, 5 in my code is 4 times 9 cubed. The 4 comes from, I've picked 5 and there's 4 places in the code it can be. The 9 cubed is the remaining digits that are not 5 can fill out my remaining 3 spots. So 9 times 9 times 9. And make sure you're careful when you multiply that out. Take 4 times 9 cubed and then divide by 10 to the 4th. And it should come out 0.2916. So the probability that your code will contain exactly 1 5 somewhere in my code is about a 29% chance. Alright, the last one of this example. A student's code contains all 5s. So that means your code is all 5s, right? All 4 numbers are 5s. So probability of the code is 5, 5, 5, 5. Well, the number of ways to get 5, 5, 5, 5 out of my universal set. Well, that's one specific code, right? There's only one way. There's only one code that's all 5s. So it's 1 out of my universal, 10 to the 4th, so 1 out of 10,000. Which, if you're careful here, your calculator will give you, I believe, 1e to the negative 4th, right? Is what the calculator spits out. And so that's the scientific notation. That means I move my decimal places over from the 4. Make sure I've written that down with scientific, like your calculator spits it out. 1e to the negative 4th. And so that means from the 1, I move my decimal place over 4 spots. And so I go 1, and then I need 3 zeros. And so this would be written as 0.0001, right? There are 4 spots after the decimal. And the 1 is where we kind of start. And so the probability of having that specific code, and that would be true for any code, whether it's all 5s or any code, there's 1 out of 10,000. And so 0.0001. So make sure you're careful, you kind of understand what the scientific notation is. Alright, next example is another marble example, because I think it's just good practice to do marbles, because students tend to struggle with these. And it's an at most case. Alright, so it's at most. So you reach in, you grab 4 pieces at random. So 4 pieces at random still means handful, it's implying handful. So it is a combinations case, so I'm picking 4 combinations. At most 1 lemon, so that's 1 or fewer, so I get 1 lemon or no lemons. So it's the number of ways to get 1 lemon. And remember, if I'm picking 1, I still need 4, so there's a hidden and statement. I need 1 lemon and 3 others, meaning they have to be other than lemon, or no lemons, right? So that means all 4 are not lemon. Out of my universal set. And so then you fill it out. Combinations, I'm going to pick 1 of the 6 lemons times 3 of the others. Well, how many others do there have? Well, there are 3 cherries, 4 ones, so we're going to pick 3 of the 7 others. Or, so you add. We're going to pick 4 of the 7 others. There's my event. All over my universal set, which there are 13 choices, and I'm going to pick 4 of them. So 13, choose 4. Alright, so 13, choose 4. Alright, so fill them out on your calculator. So up top, I'm going to have 6, sorry, combination 6, choose 1. Times 7 choose 3 is 35, plus 7 choose 4 is also 35. All over 13 choose 4, which is 715. Right. Again, if you type it all out on the calculator at once, just make sure you do the numerator first and then divide by, so make sure you put parentheses around it. I simplify the top before I do the bottom, so I do my 35, and it's really 35 times 7, right? I've got 7 35s up there. So 245 divided by 715, and then find the decimal place. And I'm going to round a couple decimal places. So 0.0343 if I round 3 decimal places. Because it's 0.34265, so I'm going to round up to 0.343. Alright, last one, and it doesn't say this in your notes, but since this is just another marble problem, I'm going to have you try this on your own. Alright, and it's one of the easier cases, exactly 2 grapes, and I'll post the answer later on. Alright, but remember, I'm picking 2 grape candies. I still need to complete my handful of 4, so don't forget to complete your handful of 4. And so that finishes up this set of notes where we've, again, 7-4 was nothing new. It was all stuff we've seen and talked about and done before. It was sort of a mixed review of, all right, let's do a check and see that you remember how to, find these different types of probabilities, find the number of outcomes in my universal set. And so we pause to sort of make sure you've got this part down before we get into the next set of notes. 7-5, if you haven't looked yet, 7-5 is a monster of a set. There are 12 pages of notes, alright? Takes me a long time to get through it. It takes me about 4 days if we were meeting regularly, so 4 hours of video on the one section. So make sure you've got this stuff down because 7-5 is a beast. And then we still have 7-6, which is a special theorem that kind of goes with 7-5. Alright, so again, we want to make sure you've got the basics down for probability before we get into the 7-5, which is conditional probabilities, tree applications, independent events, and then 7-6, which is a special theorem called Bayes' theorem, which solves a very special type of application. Alright, so this is where we're going. We'll stop there and pick that up on the next video.